Good morning, everyone. My name is Ibrahim El Ziny, and today I'm going to introduce my science project. We're going to talk about the changes of energy during the chemical reaction. First, we're going to talk about the energy changes. Okay, the chemical bonds that contain a form of energy called chemical energy. That breaking a bond that absorbs energy from the surroundings, and the formation of chemical bonds releases energy to the surrounding. We also have more like information about the energy changes. That some chemical reactions release more energy than they absorb. Some chemical reactions absorb more energy than they release. Energy is conserved in all chemical reactions. First type we have is endothermic reaction. Okay, it is a chemical reaction that absorbs thermal energy. In endothermic reaction, it is more energy is required to break the bonds of the reactants than it is released when the products form. Like we have the reactants plus the energy, it will form for me the products, but the energy required to break the reactant bonds is greater than the energy released when the product bonds form. This is the time and this is the energy as seen in the photo. You have the second type. It is exothermic reaction. It is a chemical reaction that releases thermal energy. In exothermic reaction, more energy is released when the products form than is required to break the bonds in the reactant. As the picture here, we plus the products with the energy to the reactants has the energy, so it makes the products plus the energy. So the energy is released when the product bonds form is greater than the energy required to break the reactants bonds. We're going to talk about something called activation energy. It is the minimum amount of energy needed to start a chemical reaction. Like the black that has the name on it, activation energy. This is the minimum amount of energy just needed to start a chemical reaction for the endothermic and exothermic. They require energy to start. We have the third type as catalyst. It is a substance that increases the reaction rate by lowering the activation energy of reaction. The catalyst, it lowers the activation of energy, like in the photo here, the reactants, okay? The orange one, the black one, this what lowers the activation energy. And the catalyst, it is the activation without the energy. So they both must be together. We're going to talk about enzyme. Okay, it is the catalyst that speeds up a chemical reaction in living cell. So it also, this photo regards for what before. So it's activation energy, it's without a catalyst. An inhibitor, it's the substance that slows or even stops a chemical reaction like this. It is when the reactants try to bond to catalyst, they are blocked because inhibitor bonds to the catalyst, like the photo here. We have the reaction rates. We have that the rate of reaction, it is the speed up at which it occurs. Chemical reactions occur faster if the particles collide more often or move faster when they collide. Also, it increased surface increases the reaction rate because more particles on the surface of a solid come into contact with the particles of another substance. At a higher temperature, the average speed of particles is greater, so the particles collide more often and collisions with more energy and are more likely to break the chemical bonds. We have more information increasing the concentration of one or more reactants, increasing the collisions between the particles, like resulting in a fast reaction rate. So in gases, an increase in pressure pushes the gas particles closer together, resulting from more collisions. Thank you. I hope you enjoyed the video.